Good morning, ladies and gentlemen. Today we're going to delve into some special properties that arise from the unit circle. In particular, we're going to start off what happens when the angle of interest, or here, theta, is equal to 45. Bear in mind we can call it 45 or pi on 4, and we should be using those interchangeably, one in degrees, one in radians. Particularly here, it sets up an interesting triangle, because it's isosceles. 45 degrees, and a 90 means we have this isosceles triangle of A, and 1. So we can use Pythagoras to solve for what A is. Essentially, A squared plus A squared, there those two sides, equals 1 squared, or just 1. So 2A squared is equal to 1, A squared is equal to a half, A is equal to the square root of a half, which is the same as 1 over root 2. So from that, we can get these properties, that sine of 45 is 1 on root 2, because sine of 45 is that length there. Note that that could also be written as sine of pi on 4 is 1 on root 2. You may also see 1 on root 2 written as root 2 on 2. The reason is because your calculator particularly likes multiplying things by 1, like you just see me doing there, to make the denominator rational. So calculators, textbooks tend to dislike rational denominators. If you see it written as that, that's what's happened to it. It's the same thing, it's just the different way around. Alright, cos 45 is the same, because they're both A, sine 45 equals cos 45, which is one of the only times it happens. And because tan is the ratio of sine and cos, because, well, they're equal at this point, tan is just equal to 1. So tan 45 or tan pi on 4 is equal to 1. And this triangle here, that setup, is one that essentially you're expected to know almost by heart. And with practice, you will learn that by heart. There's a second you're also expected to know by heart. And this one is set up with an angle of 60. Angle of 60 there, 30 here. Right. And the way this one works out, we can use a similar sort of Pythagoras arrangement, is that we end up with a triangle like this. Note they've multiplied everything by 2 here to make the hypotenuse 2 instead of 1, just to get rid of some fractions for us. But essentially what we have is a side of 1, 2, and root 3. Sine 30 is a half, and that's the example I keep using in class, or you could think about that as sine of pi on 6 equals a half. Cos 30 is root 3 on 2, or cos of pi on 6. And tan 30, or tan of pi on 6, is that. Here, 60, you can think of that as 2 pi on 6, or we often use a pi on 3. Essentially, you'll be expected to know all multiples of pi on 6, pi on 4, and pi on 3. In terms of sine, cos, and tan. And it does take some practice to work it out. So, on the note of practice, let's go to some examples. If I were you, I would have these down as notes in your reference book. And if you want to try and visualize what that means in terms of the unit circle, what it means is this. As the angles go round in multiples of pi on 6, that there is 1 pi on 6, 2 pi on 6, 3 pi on 6, 4 pi on 6, etc. These are the key points and what they're after. You don't have to copy that down exactly. You can just go on OneNote and print it out. Or print out that table there. Note that this is, well, in radians is 0, pi on 6, pi on 4, pi on 3, pi on 2. Okay. So you might get questions that ask, find the exact values of sine alpha, cos alpha, tan alpha for alpha equals to 3 pi on 4. Now, first step to all of these is draw a little unit circle. Doesn't have to be beautiful. And then try and visualize where 3 pi on 4 is. We know that pi on 2 is straight up. So if we're working in quarters here, 1 quarter, I hope you can see my cursor, 2 quarters, meaning a half, 3 quarters. That there is 3 pi on 4. Now, we can use the notes from above, or we can try and work out what sort of triangle we've got here. So, what sort of triangle we've got is this one here. And that angle in there choose the right colour, that angle in there, if the whole way around there was 3 pi on 4, this angle in here will be pi on 4, because the entire 180 is pi, so we've got a triangle with a pi on 4 angle inside it. Pi on 4 is the same as 45 degrees. So from above, we should know that sine of pi on 4 is equal to 1 on root 2. And that works out well here, because we can imagine that bit there, from there to there, being 1 on root 2. Cos of pi on 4 is the same. It's 1 on root 2. The only issue here is we're not asked for cos of pi on 4, or sine of pi on 4, really. We're asked for sine of 3 pi on 4 and cos of 3 pi on 4. Now, if you look at that diagram, sine of pi on 4 is going to be positive. Sine of 3 pi on 4 is still above the x-axis, so it's still going to be positive 1 on root 2. But cos of 3 pi on 4 will be the same in magnitude, it's the same size, but now negative 1 on root 2. Alright, so it's the same here, but a mirror image onto the negative side. Alright, now, this is where the A, S, T, C comes in, because you're thinking about which one will be positive and which one will be negative. In this case, only sine is positive in this quadrant, whereas both cos and tan are negative. We know that tan of 3 pi on 4 will be equal to the tan of pi on 4, but this time we're over here and it's negative, so it's going to be minus 1. Alright. So, all of this is based off that triangle and that triangle, but then applied to different quadrants going around the unit circle. So, for example, here, same sort of problem, but we're asked for 4 pi on 3. So, let's look at where 4 pi on 3 falls. 1 pi on 3 will be out here, 2 pi on 3, 3 pi on 3 is there. Down here is 4 pi on 3. Which means this angle here, or the reference angle we're working with, is pi on 3. Alright? Or 60. So then we can flick up to our notes and look at what sine 60, cos 60 are. Well, cos 60 is root 3 on 2. Sorry, sine 60 is root 3 on 2, cos 60 is a half. So if we're looking at here, cos of 4 pi on 3 would normally be positive a half if it was just pi on 3 out this way. But because we're out the other way, it's negative a half. Similarly, sine 4 pi on 3 will be equal to negative root 3 on 2. And tan of 4 pi on 3, well, tan of 60, if we go to our table, would normally just be root 3. But down here, we know that both of those are negative, so it's still going to be positive because tan is the ratio of the two, so it's still positive root 3. Alright, last one. Second to last one. I lied. Alright. Without using a calculator, show that 8 sine pi on 3 times cos 5 pi on 6 is equal to minus 6. Alright, let's treat this in parts. The 8 we don't need to do anything with, we can just leave it there. Sine pi on 3 we know is essentially definitional. For us, it's one of the fundamental ones, it's just root 3 on 2. Here though, 5 pi on 6 for cos is a little more difficult. So think about that in terms of unit circle. 5 pi on 6 is going to be 5/6 of the way around. It'll be out here with a little pi on 6 there. Pi on 6. And cos is going to be this angle here. Sorry, that length there. This angle is pi on 6. So then really we're looking for cos of pi on 6. That pi on 6 is what we call our reference angle. Cos of pi on 6 is root 3 on 2. So we head down here, and it's going to be, because it's on this side for cos, negative. So negative root 3 on 2. And all of these are multiplied together. So if we multiply these together, that becomes minus 3 over 4. which when we multiply those together is minus 24 on 4, which is just equal to minus 6. Alright, sorry, no, it's a long video, but examples are good. Find all the angles between 0 and 2 pi with a cosine of a half. Alright, so we're looking here. And what we're looking for is, when we draw a triangle, this portion here is positive a half. And the first one we can pick off in there is pi on 3. We know that cos of pi on 3 is equal to a half. That's one of our definition ones. But we can think about a second option down here. There is a second option down there. So that must also have this same reference angle of pi on 3 there. There must be another pi on 3 there. So what we're thinking is that's 2 pi take pi on 3. Or 2 pi take away pi on 3. Different ways to think about this. I guess we could think about 2 pi as 6 pi on 3. Take pi on 3 equals 5 pi on 3. So our second solution here is 5 pi on 3 because cos of 5 pi on 3 is equal to a half also. Alright, I know that was a long video. Thank you very much.